Hello everyone, in today's video we are going to see about standard Calomel electrode. This is one of the most important topic also. We will see how it works and what are the substances which we have to use in order to measure the electrode of the electrode potential of the electrode. Okay, so this consists of a glass tube which has two tubes. Okay, one on the left side and the other one on the right side. Okay, after that at the bottom of this glass tube or glass vessel we have to cover it with the pure mercury is nothing but Hg. Okay, after placing the mercury we have to cover that with the paste of Hg and Hg2Cl2. Okay, and then using the right side tube we have to pass the KCl solution into this glass vessel, potassium chloride solution. Okay, and that potassium chloride solution is a known concentration, that means we have to measure the concentration of it. After that we have to fill the KCl solution in the complete tube, right? After that this KCl solution and the left side tube will help us to measure the other electrode potential. Okay, whatever the potential or whatever the voltage we are trying to find out of a particular electrode, this KCl solution will help us to find. And along with this KCl solution we will also use salt bridge. Okay, through this tube only we will find the potential of the other electrode, and in this KCl solution and we have salt bridge as well. So salt bridge acts as a membrane which will help us to transmit ions from one end to the other end, or it will help us to move the ions faster in the solution or in the glass vessel. Okay, and after that a platinum wire is sealed into the glass tube. So here a platinum wire is sealed into the glass tube which is in contact with the Hg. That means whatever the paste we have kept at the bottom, so the now platinum wire we are inserting from here, right? That platinum wire should touch the paste of the Hg. Okay, that is what the important point. After that it should be a sealed one, that means a closed one. No air should be passed into the side, into the glass vessel. Okay, so now after that what we have sealed this one and we have to close this tube also. Okay, left side tube. Now the reactions, whatever the reactions taking place, we'll see. Now what happens is this is a mole concentration. Okay, 0.1 m. This is the concentration of the KCl which we have used. We have discussed, right? Known concentration of KCl solution we have to take, and that is what here means 0.1 m molar. Okay, KCl and Hg2Cl2 which is a solid substance because we have used paste, right? And Hg pure mercury we have kept at the bottom, and then platinum it is which is of 0.33 volts. Okay, this is of 1 mole. Okay, these are the concentrations, and the reactions are Hg2Cl2. Whatever the paste we have used in this glass tube, we have also seen this kind of thing in the galvanic cell, right? We will use electrolyte and that will help us to move the ions. So similarly here Hg2Cl2 will act in that way. So this will lose 2 electrons to give a solid substance of 2 Hg and plus 2 Cl minus. And now this chloride ions, whatever the chloride ions released, this will be absorbed by the electrode which we are measuring the potential. So in the left side tube we have sealed it here, right? So we will connect one salt bridge and we will use some electrode, whatever we are trying to measure the potential of that. So this Cl minus whatever released will be mixed with the, or it will be charged up with the electronic ions of this other electrode which we are measuring. So this complete reaction is this one. Okay, Hg2Cl2 plus 2 electrons gives 2 Hg plus 2 Cl minus. This is reaction will be happening inside the glass tube, and the 2 Cl minus electrons whatever the released, that will be absorbed by the other electrode which we are trying to measure the potential of that. Okay, now we will see some advantages and disadvantages of this. So advantages is concentration of the Cl will be constant, Cl minus ions. Okay, this concentration will be constant, that will not change. And pH also can be measured by combining the hydrogen or quinhydrone on glass electrodes. So how we have to measure the pH of that solution means using the hydrogen or quin hydron or glass electrodes, and this is very uh, cost effective. That means this is very inexpensive, and then easy of oxidation and reduction reactions. So for the oxidation and reduction reactions, that means losing of these electrons and then charging up with the other electrodes. So all these reactions doesn't require any external pressure or any external substances. Okay, it happens inside the glass tube only, that too very easily. And the disadvantages is solubility of KCl is sensitive, that means it will dissolve very easily. Okay, and the KCl has to be replaced time to time. Why we have to replace the KCl solution? Because this is very sensitive and it will get dissolved in the solution very quickly, and the reactions will be taking very faster. So we cannot measure the electrode potential of the other electrode that fastly. Okay, and then mercury is toxic and poses health hazard. So we all know that mercury is we have to use very least amount, and if that mercury is exposed to air, that will cause some toxic substances into the air. So we have to be careful with the mercury as well. And these are the merits and demerits and the standard Calomel electrode. Okay, thank you.